So hello everyone. So we are doing in-depth analysis of web graph structures using advanced clustering techniques and graph metrics. So we are using Hadoop and Apache Spark for that. So here are my group mates, Avinash Tiwari, Ayush Singh myself, and Nachiket Ganesh Apte. So what is the aim of our project? So the project aim is to analyze web graph structures using advanced clustering techniques and graph metrics. So we are we are using Hadoop and SparkX for executing our codes on multiple machines. So what is Hadoop? So Hadoop is a distributed computing framework. Hadoop is an open source framework for distributed storage and processing for large data set. It has mainly two features. HDFS. It provides a reliable and scalable storage solution by distributing data across multiple nodes in a cluster. Data is replicable for fault tolerance. And the second one is MapReduce. So basically what does MapReduce does? It breaks the code into multiple parts and runs on different machines, and later it combines the output. So what is Apache Spark? Apache Spark is an framework for Hadoop. It is a computing engine. It is fast, and it is made for large scale data processing tasks. Nowadays it has versatile APIs which are used to train machine learning models also, and it interacts with high level languages like Java, Python, etc. So the web graphs we use mainly include graphs from Google and Stanford. So a graph, what does a web graph represent? So a node in web graph is a web page or an HTML page, and the edges are nothing but hyperlinks between them. It has many important applications like search engine ranking, web crawling, etc., etc.
So thank you, Ayush. Now I'll be continuing with the execution of the program. Now let's look at the Hadoop overview page. Now as you can see, there are two live nodes. So we have set up a cluster of two nodes, mine and Ayush's laptop, and this is the applications page where you can see the list of all the applications that we have either submitted or they are currently running. Now if you go to Spark Master 8080, you can see that there are two worker nodes, that is mine and Ayush's. Now let's take a look at the code. So if you go to Java, this is the graph metrics app. This is the code that we are going to show for the sample execution because it takes lesser time. Now let's take a look at the code. So this is the graph metrics app code that will be showing for execution because it takes lesser time. Now it is using default classes and libraries of graphics, for example edge, graph, and from the package of lib it's using triangle found count for calculating the number of triangles. Now these are the data sets from the parts of the data sets, that is web Google and web Notre Dame, and it is going to store the results in the local file metrics result using buffered reader. So it's first converting the data set into RDT, and then it's converting it reading it as a graph and a triangle graph respectively, and then it is performing the calculations as per requirement. Now let's look at the commands that are used to run. So after uploading the data sets, we'll have to also create this directory where Spark can store the logs of the process that it's running. Right now let's run this code Spark submit so as to run our code. Before doing that, we'll have to do mvn clean package, that is maven clean package, so that it builds the new jar file of all the classes that are present here. So when we do that, as you can see on the left hand side, it will get deleted and a new jar file will be generated. It will be of the same name, so we don't need to change the name here. So Spark submit, if I copy this command and paste here, so it is asking for launching AM containers, and it's uploading a temporary resource file for Spark to Spark for execution. So if we go here, it's not yet started. We'll wait for it to start. Yeah, so it has started. Now as you can see, accepted, and it's running. Now if you go to application master, now Spark context will start in 1 or 2 minutes. So let's just reload this. See, it has started. Now if you click on application master, it will redirect us to the Spark jobs Now here you can see the event timeline when the executors were added and what process it is currently running or it has run. Now fold, that is, it is converting it into RDT and counting the number of vertices. After, now we have to reload it because this is a static page, so we have to continuously reload it for C. So it's performing count for the graph 1, which is Google. Then it will proceed to perform the count for graph 2, which is the Notre Dame graph. Let's just wait for a few seconds for it to finish. Now this will take about 5 to 10 minutes, or depending upon the processor or the number of nodes connected. Now since we have only a 2 node cluster, it is taking a little bit larger amount of time. Now you see it has completed the count for first graph. So that means all the processes have been completed for the first graph. Now it's performing for the second graph, that is the Notre Dame graph. Now this has also been converted and now it's at count graph metrics, that is for the second graph. Okay, so the program has finished execution. Now as you can see, now this is the logs file. Now generally the output will be here, but since we have used buffered reader, so it will be, the output will be stored in our metrics results. Now as you can see, these are the stats for graph 1, that is Google's graph, and these are the respective nodes, edges, and the weakly connected component nodes and edges, and this is similarly for graph 2. Now I'll be handing over to Avinash for discussing the results.
Thank you, Nachiket. So now I will guide you through the results. I am Avinash Tiwari. So let's continue to the results. So first we will see the result of community detection. So the Web Google dataset revealed a heterogeneous community structure with a significant number of detected communities totaling over 2000 distinct groups. The largest community encompasses more than 8 lakh nodes, indicating a very central large cluster which suggests a hub-like formation in this network. The size distribution of the communities varies considerably, reflecting the diversity of interaction or connectivity density within the Web Google network. Some communities consist of very few nodes, indicating very tightly knit, possibly high specialized connection. The findings of Notre Dame, unlike the Google, are characterized by monolithic community structure with a single community comprising all 3 lakh plus nodes, which implicates that single community suggests that the Web Notre Dame network is highly interconnected, lacking distinct modular structure which are prominent in other networks such as Web Google. This could imply that the Notre Dame web structure serves a more unified or less diverse set of topics or functions compared to the vast and varied landscape found in Web Google. So here is an animational view. Now we will see the implication of triangles algorithm. The number of triangles represent the total number of unique triplets of nodes that are mutually interconnected. The fraction of closed triangle is indicative of tendency for the nodes to create tightly knit, mutually reinforcing relationship. Higher percentage reflect a network with numerous tightly knit communities. The higher fraction in Web Google dataset suggests a slightly more closed network structure compared to Web Notre Dame. Now we will see the SCC and WCC algorithm. So in both dataset, all nodes are part of largest weakly connected component, indicating that from any given node, there is a part to every other node when directionality is ignored. This suggests a very high level of connectivity within each graph. The presence of single WCC encompassing all nodes and edges signifies a robust network structure where information can freely flow across the entire network. Now we will see the page rank results. So the page rank results highlight the nodes with highest influence in their respective networks, indicated by the page rank score. Nodes in the Web Notre Dame dataset exhibit higher page rank scores overall compared to Web Google, suggesting more pronounced centralization around key nodes. So the higher page rank pages could be pages of news articles and pages which can be used to spread information. So thank you very much.